Okay. Now tell me whether can I index into this page table using simple addition? I can definitely do that. Why? Because this is placed in contiguous addresses, right? See, this will also be placed in a single frame of RAM. Now, if I take this page if I take this page table and if I place it in a single frame, let me assume that I am placing it here. Okay, I have placed in a single frame. In case if I place it, this a complete table is placed in contiguous addresses in the RAM, right? So definitely I can apply simple. I can index into this page table using simple addition. Okay. Now how will I do that? That is the biggest question, right? Here how did I do this? Do that? What I did was I had page table base address. Using that address, I went into this table. Okay, I went into this table. After reaching this table, in order to index into this page table, which means in order to find out the entry number, I use something called as page number field, right? In case if the page number is 1, I went into the entry number 1. Now after going into this entry, I will be able to get the frame number, which means I will be able to reach this frame or this frame, any frame. After reaching this frame, I use the page offset and I fetched the byte and gave it to the CPU so that CPU can execute it, right? That is what I have been doing. Now how I can index it? Okay, now I need to start from here and I need to come here and then I need to take the exact byte. Now how this is done? See, one thing you need to understand from this is whether I use single level paging or multi-level paging, our CPU doesn't know anything, right? Our CPU doesn't know whether I am using single level paging or multi-level paging. So it will obviously generate the same logical address. Okay, it doesn't matter whether I use single level paging or multi-level. See, in case if I have say 0111011, if this is the address generated by CPU as logical address here, the same will also be generated over here. Okay, it will also be the same 0111011. It is just a random address. Okay, so what I want to tell you is whether you are using single level paging or multi-level paging, our CPU doesn't know anything. It will simply generate the logical address. Now, in this logical address, what we did was we had two fields, right? Page number and page offset. So what I want to tell you is somehow, let us assume that somehow we know that this is page number and this is page offset. Now using the page number, I completely reached the frame in which my byte is present, right? And after reaching that, I used this page offset in order to get the exact byte within the page, right? Within the frame. So one thing you need to understand is using this page number field, I am completely able to reach the exact page in which my process is present. It is not in which my page table is present. Okay. See, ultimately our goal is to fetch a byte within the process, right? We use page table just to show the direction. Okay, just to show the direction or just to show the place where my byte is actually present. Our ultimate goal is actually to fetch the byte and execute it. And so what I want to tell you is this page number, using this page number field, I am able to reach the exact byte within the page, and after reaching it here, I use the page offset field in order to find the byte number. The same is what we should be doing here as well. Using this page number field, I should be able to reach the exact process. Okay, exact process. It can be either this page or this page or this page, whatever, depending on the address, right? I should be able to reach one among these three pages. Why? Because these are the pages which are holding the process, right? See, this is holding page table, this is holding page table, and this is holding page table, right? These are the pages which are actually holding our actual process, which means holding the bytes of our process. Now using this page number field, I should be able to reach one among these three pages, right? One among these three pages. Now after reaching these three pages, it is very straightforward. It is exactly like this. We use the page offset field in order to choose the byte within the page. Okay, in order to choose the byte within the page. Now how this exactly happens, we'll see that in the next video. Okay, it is not that difficult. It is easy actually. So what I want to know now, one question you might ask is, using this page offset field, using the page number field, we were able to reach here, right? How did we do that? Using this number, we choose the entry number. In case, see here it is 3, but here we don't have entry number 3, right? So we will not get a logical address like this. This is an invalid logical address. Let us assume our page number field is having 001. Now what will happen? If it is 001, it is nothing but page number 1, right? Now in order to find out the frame in which page number 1 is present, I will go into the entry number 1, right? Now after going into the entry number 1, I will get the frame number and I will replace this page number with the frame number, so that I will be able to go to the frame number, and within the frame I use this offset in order to get the byte. Okay, I know I'm repeating it, but still I want to make it very clear. Now what I want to tell you here is, here also we use the same page number, but we need to index into two levels of page tables, right? Here we use this page number in order to index into one level of page table, right? See, using the base address we reach this page table. Now after reaching this page table, in order to index into this page table, we use this page number, right? Now the same is what is happening here. Using the page table base address, I will reach this page table. Fine. After reaching this, I need to index into the page table. After indexing into the page table, it is straightforward, right? I will be able to reach this level, which means this will show the address direction over here. After reaching it, again I need to index into this page table as well. So I need to index into two levels of page table using this single page number field, right? Now how I will do is, I will split this address. Okay, this address will be splitted. After this address is splitted, what will happen is, we will use this part in order to index into this level of paging. Okay, now once I index into this level of paging, it is very straightforward, right? See this, it is holding a number. Let us assume the number is 001. Okay, the address is 001. Now it is showing, let us assume this is how I have split it. Okay, now how did I do the splitting? We will see that later. Okay, it depends on addresses. We will see that. Now we have split this page number. See, this is page offset. Okay, don't get confused. This is page offset and this is the page number field. Now we have split this page number into two regions. Now using this region, I will index into this page table. Okay, let us assume using this page, not let us assume, it is the exact point. Using this page table base address, I reach this table. Okay, after reaching this table, I saw the logical address, and using this bit is indicating 0, right? So I will go to 0th entry. Now once I go to the 0th entry, I will get the frame number. Which frame number? Frame number in which this page is present, right? Because this is pointing to this. And so once I reach this entry, I will be able to reach this frame, right? Because this entry is holding the frame number of this page. Now using this, I will be able to reach this frame. Fine. Now after reaching this frame, I need to index into this page as well, right? I need to index into this page table as well. For that I use this number. Now after reaching entry number 1, again I will hold the frame number in which this page is present, right? So using this frame number, I will reach this page. Okay, I have reached this page. So finally I have reached the process. Now within the process or within the page of a process, see, this page will also be present in a frame, right, in a RAM. Now after reaching this frame, there will be a lot of bytes in this page. Now I need to choose one byte among all the bytes in the page. For that I use something called as page offset. Okay, using the page offset, see what is actually being indicated, that is not important. Using this field, whatever number this is representing, I will go to that exact byte number and I will get the exact byte from the page and give it to the CPU. Now once the CPU gets the byte, it will execute that byte and then again it will continue with the next byte, which means this, in a similar manner it will again start coming and then will fetch the next byte. This is what is happening overall. Okay, so you got a brief idea of multi-level paging, right? Multi-level paging, here we have used two levels of paging, right? Now why did we stop it here? Because here our entire page table is, we are able to place the outermost page table within a single frame, right? So we stopped it here. In case if I would have got even two page tables over here in this level, when will this happen? In case if the page table size is greater than this frame, which means let us assume I had 3 entries. In that case I placed 2 entries over here and 1 entry over here. In this case I need to again create one more level of paging where the first entry will hold the address of this and the second entry will hold the address of this. Okay, this will keep on happening as long as we are able to place the outermost page table in a single frame of RAM. We will keep on creating levels of paging. Okay, so let me erase this page table. Okay, so here we have only one. Here outermost page table is present in only one frame, so we can stop it here. So what I want to tell you is, we use page number field in order to get the exact frame of our process. Now after reaching the exact frame, we use the page offset field in order to get the byte number within the process. Now the challenge is, how will we be able to how will we be able to reach this process using this page number field? For that, what we do is, we split the page number into two regions, right? Now why are we splitting it into two regions? Because we have only two levels of paging. Here we had only one level of paging, right? So we didn't split it. We had only one region. And using this region, I'm able to index into this page table. But here we have two levels of page tables. Here we have two levels of paging. And so I have split this page number into two regions. Using the first region, I indexed into the first level of page table. Using the second region, I indexed into the second level of page table. And using these two regions, I'm finally using these two regions or using this page number field, I am finally able to reach the page of process. Now after reaching, using the page offset field, I am able to pick the exact byte. Okay. So anyway, we have not seen multi-level paging completely. Okay. We have seen only the basic idea. Actually, there are a lot of points still to cover in multi-level paging. For example, we didn't see how will we find out which is the page number and which is the page offset in the logical address, right? CPU will simply generate logical address, something like 0011100 or whatever it is, some binary number. Now whether this is page number and this is page offset, or this is page number and this is page offset, all these things we need to find out, right? Now how will we find out this? All these things we didn't see till now. Okay, so what I want to tell you is, we are just starting off with the basic idea of multi-level paging. We didn't get into the exact details. Okay, once we see some example, it will be very clear.